All right. So let us start with the last question that I took. Let me write that first. Then I'll take up the thing that I have to take today. Now your question was, this was the question, fxyz, sorry, is equal to 5xyz.
By x plus 2y plus 4z.
Uh,
Find
and
xy for which f xyz is maximum given that xyz is equal to 8.
okay, so we could solve till how much? What is the value of x, y and all you have calculated?
मैम gx निकाले था उसके बाद xy में रिलेशन आ गया था लेकिन वैल्यू नहीं निकली थी.
क्या क्या आया था? एक इक्वेशन ये आया था इफ आई एम राइट, और एक इक्वेशन ये आया था, राइट? ये आया था नहीं आया था?
यस मैम, ये एक इक्वेशन आ गई थी जो आपने ऊपर लिखी थी.
और ये वाली दूसरा वैल्यू इक्वेट करोगे जीरो से तो ये आ जाएगी. चलो, आई एम डूइंग इट अगेन, जस्ट सी. वी हैड एफ एक्स वाई जेड is equal to 40 upon x plus 2y plus 32 upon xy. So f is maximum if this is minimum. I hope that understanding is clear.
यस मैम.
Okay, so let us assume this as g. I think I had given this as g.
यस मैम.
So gxy is x plus 2y plus 32 upon xy. So for maxima or minima, we do like this. This means 1 minus 32 upon x square y is equal to 0. And del g by del y, 2 minus 32 upon xy square equals to 0. These two has given me this. You can multiply and see. X square y is 32 and 2xy square is 32. Now we have to solve this for x and y. Please solve and give me the value. I hope this much is understood. How do we solve it? Very simple way. Here you have y is equal to 32 by x square. Please put it here. If I mark this as equation A and this as B, from A to B. So y is 32 by x square. This means 2 into x into 32 by x square ka square is 32. This means 2 into 32 is x to the power 3. Is this okay or not?
Yes, ma'am.
So if this is okay, that gives us x as, this is 16 into 2. So 4, 64. So this is 4. Is this fine?
Yes, ma'am.
If x is 4, that means y is, you put it from here, 32 by 16, that is 2. So what is our stationary point? Our stationary point is 4, 2. Right? Stationary point that you have calculated is, now we need to know what is the second derivative. Your z is, what will be the value of z? 8 upon xy and that is 8 upon 8, that is 1. Okay. Now find the second derivative. What is del 2u upon del 2g upon del x square? What is that? Just see from here. See, this is your del g by del x. So del 2g by del x square is minus plus 32 into 2 upon x cube y. Right? So let's write it. You are differentiating it with respect to x. Remember that. So what do you get? This part will disappear. This is x to the power minus 2. So that is minus into 32 into x to the power minus 3. So if I write it, it will be, it will be 64 upon x cube y. Right? So when you put the value, this is 64 upon 4 cube into 2, and this is 1 by 2, which is positive. And this is what your r. Now let's try other values. When I find del 2g upon del x del y, what will it be? It will be 32 upon x square y square, and that is 32 upon 16 into 4, and that is 1 by 2. Please check. Is this okay? You are differentiating this with respect to y, so it will give you y square. Minus minus will become plus. Then find del 2g upon del y square. Part 3 you are not responding.
I understand.
So this is 64 upon xy cube. So that is 64 upon 4 into 8. That is 2. Now this is your P, this is your S. So we have to check it for RT minus S square. R is half, T is 2, S is half square. So this is 1 minus 1 by 4, that is 3 by 4, which is positive. Right? So now RT minus S square is positive and R is positive. What is it? Condition of minima. Huh? So G is minimum. You can write it as this is positive and R is positive. This implies minima. Hence, G is minimum at 4 to 1. So, F is maximum at 4 to 1, and maximum value of F is equal to 5 into 8 upon x plus 2 आई थे ना, x is 4, 2 into 2 plus 32 upon 4 into 2. So this is 40, 8, 4, 4 plus 4 plus 4, 12. Right? Though it is not what is the minimum value or what is the maximum value, the question is at what point it will be maximum. ये क्या होगा? ये होगा 10 by 3 is the value. I hope the question is understood.
Yes, ma'am. आगे समझ लो.
Let's do one more question, then I'll proceed to the next concept. Find the volume of the largest rectangular parallelepiped that can be inscribed in the ellipsoid x square upon a square plus y square upon b square plus z square upon c square equals to 1. This is your function. You have to check for maxima for a parallelepiped. So parallelepiped you can think of as a cuboid. Okay. So whenever we have to do this kind of question, we try to take dimensions in largest rectangular parallelepiped. That's the question. So volume is LBH, right? When you are saying largest, that means you are talking about volume.
Yes,
So let's assume L as 2x, B as 2y, and H as 2z. Okay, this is we are taking for the sake of convenience of calculation. So your V is 2 into 2 into 2, that is 8 x, y, z. Now you are looking for maxima for this. Okay. Now since the things are given in a square, it is convenient if we do it like this. And assume this as some other function. Okay, so let's see. We can write it as 64 x square y square. Now see, I am replacing z. C square 1 minus. Is this fine?
Yes, ma'am.
We have converted it in two variables. Okay, and let this function be fxy. Let this be fxy. So fxy is 64 c square, which is treated as a constant. Then if you want, you can put this x square y square inside. Now you have to look for maxima for this. Wherever f is maximum, v will be maximum. Is it agreeable?
Can you repeat?
Wherever f is maximum, v will be maximum there.
Yes, ma'am.
So please try and find the maxima for this. So what we will do? Del f by del x. What is that value? 64 c square 2x y square minus 4x cube y square minus 2xy4 b square equated to 0, and del f by del y 2x square y 2x4y 4x square y cube okay. Now when you equate this equals to 0, if you see x y square is common, so I'm simplifying this. 2 is also common, so if I take out 2xy square, it will be 128 c square xy square, and what is inside? 1 minus Here what you will get? You will get x square. Let's check. 2x square. 2x square upon a square minus y square upon b square. This side. And when you equate this here, you will get 128 c square x square y 1 minus, here you will get x square upon a square minus 2y upon b square. Is this fine? Are you able to comprehend? Now, there are two factors. One is x, rather three factors, x, y and this factor. And this is equal to 0. Clearly, x and y can't be 0. So, what should be 0? Why am I saying that x and y can't be 0? Because the parallelepiped should have some dimension. Right? So, what we will get? This is 0. Is this fine? Now solve for x and y. I want the value. It's very easy to solve. You take the difference. Okay? When you take the difference, suppose I mark this as equation. I mark this as equation 1 and this as equation 2. 1 minus 2 will give you minus x square upon a square plus y square upon b square equals to 0. This means y is equal to bx by a. Sorry, bx by a. Is this fine? We will not take negative values. क्यों नहीं लेंगे पता है ना?
लेंथ नेगेटिव नहीं हो सकती.
Correct. So this is the connection. Now you can put it in any of the equations. Chalo, let's try and put it in the equation. Suppose I put it in first equation. I am putting it in first equation. So 1 minus 2x square upon a square minus b square x square upon b square a square equals to 0. So 1 minus 3x square upon a square is 0. X is a by root 3. So if x is a by root 3, that means y is, what will you get as y? B by root 3. And hence z is 1 minus, what will be z? C square 1 minus so this is the value of A, B and C. I hope it is understood. Now we need to find R, S and T at these points. So let's try and find out. Del 2f upon del x square. I'm differentiating, just check. 64c square just a minute, see the function. This is no, this is the first derivative. So differentiate first derivative. Now I'm writing the c and check me if I'm not correct. 64c square 2y square minus 12 x square y square by a square minus 2y4 upon b square. This is your r. Del 2f upon del x del y is 64c square 4xy minus 8x cube y upon a square minus 8xy cube. This is your s, and del 2f upon del y square, sorry, this is square, 2x square minus 2x to the power 4 by a square 12x square y square upon b square, and this is your t. Now put these values and see what will be your r. Give me the value of r. R is equal to what? Substitute and see. Do I put the value here? So R is equal to 64c square 2b square by 3 minus 12 a square b square upon 3 into 3 into a square minus 2 b to the power 4 upon 3 into 3b square. So when you simplify this, 4 2 by 3b square, 4 by 3b square, 2 by 3b square. So this and this will be cancelled. Only 4 by so this is 2 by 9, 2 by 3. So what is the output? 6 minus 2, that is 4 from here. 4 by 3. Just check what value you are getting. 4 by 9 minus 4 by 3. So 12. 8. You will get 8 by 9 b square with minus sign. So actually 8 4s are 32, 8 6 are 48. Minus 512 you will get. Please check this. Similarly put the value here. So this is minus 512 by 9 b square c square, which is less than 0. Put the values and give me the output. What is S?
मैम कितने मार्क्स का क्वेश्चन आएगा ये इस तरीके का, क्योंकि ये काफी
8 marks beta at the most.
ओके.
Give me the output. I'm waiting. What is the value for S?
minus 256 ABC square by 9.
Correct. And T? T is of similar pattern. See? So whatever I have got here in place of B, I should get A. So I'm writing it, but I want you to test. Now let me check for RT minus S square. So 512 is double of 256, right? So I'm taking out 256 by 9 square as common. Now here we have a square, b square, c to the power 4. Here we have a square, b square, c to the power 4. So I'm taking that also out. What is left with me? I have 2 here and 2 here. So that is 4 minus 1. So that is 256 by 9 square into 3 into a square, b square, c to the power 4, and this is positive. Now you need not to calculate it exactly, just the thing that you have to show is that this is positive, that's all. So by taking out common, I could show that this is positive and r is negative. So if RT minus S square is positive and r is negative, that means point of maxima. Okay, so maximum volume, V is maximum at A by root 3, B by root 3, C by root 3. And maximum volume is equal to 8 A by root 3, B by root 3, C by root 3. That is 8 ABC upon 3 root 3. Is it understood?
Yes, ma'am.
One more question, or do I take next concept?
One more.
Chalo. Do I clear it?
Just a second.
Okay. Finish, then I'll clear.
I'm completing.
Done? Chalo, write next question. The sum of three numbers is a constant. Prove that their product is maximum when they are equal. Hmm? So what this question is stating, this question is saying that you have three numbers x, y, z, and what is given, that some of the numbers are constant. Hmm? You have to show, if P is the product, then you have to show that P is maximum, to show P is maximum when x is equal to y is equal to z. This is the thing that you have to prove. Okay. So first thing, we have to remove one variable, and that is z. So we can write P is equal to xy c minus x minus y. So that is cxy minus x square y minus xy square. All right. So you have to show that this is maximum. So the process is simple. Find del p by del x. So that is cy to xy minus y square, and del p by del y is equal to cx minus x square minus 2xy. Okay. Now equate it to 0 and equate this to 0. Obviously y can't be 0. The numbers can't be 0 because otherwise the product will be 0. So what will you get here? This means when you are putting this as 0, taking out y as common, so what you are getting, this means y c minus 2x minus y equals to 0. So y is equal to c minus 2x. Is it okay?
Yes, ma'am.
Now here what you will get? You will get x into c minus x minus 2y. So x is equal to c minus 2y. So we put y from here to here. This means x is equal to c minus 2, c minus 2x. So this is c minus 2c plus 4x. So we got 3x is equal to c. So x is c by 3. Is this fine? Hmm? When you get x is c by 3, y is c minus 2c by 3. So that is,
It is 4x equal to c.
नहीं बेटा एक x भी है ना इधर, x is equal to this ना, just check.
Okay, okay, ma'am.
So here you will get c by 3. When x is c by 3, y is c by 3, obviously z is also c by 3. Okay. Now find second derivative from here. So second derivative from here will give me minus 2y. This part will be 0, this part will be 0. Del 2p by del x del y that is C minus 2x minus 2y, and del 2p upon del y square is minus 2x. Please check this. So let me put the values. So r is equal to minus 2c by 3, s is equal to c minus 4c by 3. So s is minus c by 3. Just check. Put the value here. C minus 2c by 3 minus 2 by c by 3. So that is minus 4c by 3. So it is minus c by 3. And t is, now rt minus s square is minus 4c square by 9.
मैम
Something is wrong.
मैम आर भी तो माइनस माइनस 2c/3 होगा.
हाँ, माइनस 2c/3 है. यहाँ एक माइनस मिसिंग है. तो ये हो गया प्लस माइनस इंटू माइनस प्लस हो गया 4c square by 9 minus c square by 9. So you are getting 3c square by 9, that is c square by 3, which is positive, right? So rt minus s square is positive and r is negative, that means maxima. Agreeable?
Yes, ma'am.
Your r is, this is negative and this is positive. So r is negative and rt minus s square is positive, maxima. So P is maximum at C by 3, C by 3, C by 3 means is this fine? Now let's do one more question. Right, next question. Find the semi-vertical angle. Find the semi-vertical angle of a cone of maximum volume and of a given slant height. Maximum volume and given slant height. L. So first of all, we need to know what you have to find. What is the semi-vertical angle? I hope you remember the semi-vertical angle of a cone. Okay. This is semi-vertical angle. This is slant height. So obviously, if you find this radius is L sine theta and height is L cos theta. Is it okay? So volume of a cone is 1 by 3 pi r square h. So that is 1 by 3 pi L sine theta square L cos theta. You have to find V maximum. And what is your variable? Now luckily this is in one variable, and that variable is theta. It's very simple question, so I don't want to continue with this. You solve it fast. It is converted in one variable because it's fixed. That means that this is class 12th question. Do you remember this question?
Yes, ma'am.
So I'm leaving it. I thought it has two variables, but it has just one variable. I want to take up the concept that we have to deal with next. Just basic we will understand today, and then we will take up the questions in the next class. And that is the concept of Lagrange's multiplier. This is a special method. This method is used when we have a function and we have certain restrictions imposed on the function. Okay, let's try and understand. Sometimes it is necessary to find the extremum values of some function connected with one or more conditions. This is something you need to understand. When do we use it? When the functions are connected with one or more conditions. Suppose we have to find the extreme value of some function and we have to also satisfy another condition uxy, then we use this. Now how this question looks like? This question looks like, if fxyz be a function of three variables xyz and variables are connected by some relation given by phi xyz equals to 0, then f xyz to have stationary values, this should be 0, this should be 0, and this should be 0. It can be, in other words, you can say du is 0 when you say, or df is 0, because this is the total derivative. I hope you remember this. This is the total derivative of f, right? How do we represent total derivative? Del u by del x into dx, del u by del y into dy, del u by del z into dz, right? So 0, these are individually 0, you can multiply them and get this as 0. Is this fine or not? Hmm?
Yes,
Is this condition understood? Okay.
yes, ma'am.
Using total derivative for phi, you will get this. Because phi xyz is 0, so d phi will be 0, and d phi is this. Is it fine?
Yes, ma'am.
So what you have taken? You have taken total derivative this way. Here you took the points of stationary values and multiplied it with dx, dy, dz and made it 0. Here you already have this value as 0 and then you took its total derivative and find this as 0. So 2 is formed and 3 is directly generated from 1. Okay. Multiplying relation 3 by lambda and adding it with 2. So see what you will get. You will get this into dx, this into dy and this into dz. Okay. Since the right side is 0, we will put this individually 0, 0, 0. So this is 0, this is 0 and this is 0. Okay. Solving 4, 5 and 6 for lambda. For finding values of xyz and value of lambda to get a stationary value for the function this fxyz. The process is very simple. You write the function L. This is Lagrange's function, and Lagrange's function is equal to f plus lambda phi. Differentiate the Lagrange's function to get del L by del x, del L by del y, del L by del z and equate it to 0. When you do this, you will find these three ratios equals to 0. Okay. In case if fxyz be a function of three variables, the variables are connected by some relations given by this and this, Then you will construct, suppose you have two relations, then you will construct the Lagrange's function with two lambda values and so on. And then solve for lambda and get the answer. Okay. Now this is the process, but there is one very strong drawback of Lagrange's method. Lagrange's method gives us a stationary value, but it doesn't give us which kind of stationary value we are going to find. That means, is it minima or is it maxima or what? So generally what is asked, we assume it is that. Okay, I'll tell you what does it mean. Suppose you have a point in the plane this, at which the given function this has a minimum value. You have to find a point in this plane for which this has minimum value. That means what are the things given to you? Just try and understand. This is the function and this is the condition. Means this acts as f and this acts as phi. Right? Now when you will write L, Lagrange function, see, the Lagrange function is this plus lambda times this. You put the value. Okay. Then you find del L by del X equals to 0, del L by del Y equals to 0, del L by del Z equals to 0. You got this, this and this. So you try and find X in terms of lambda, Y in terms of lambda, Z in terms of lambda. Then you put this value of X, Y and Z in the condition that is given to you, and that is the condition 2. Once you put these values, you are able to find lambda like this. Okay? And this gives you X, Y and Z. Once you know X, Y and Z, you simply find F on these points. And whatever is asked, like it is said it is minimum, then we assume it is minimum. And this is the minimum value. That's all. Are you understanding? There is no method to tell us whether it is extremal value is minima or maxima. We simply find lambda and xyz and we put it in the function, and whatever we get is okay. That is accepted. Is that okay? Sometimes it is the only necessity is to find the critical points. It is not of much interest to us whether the critical point is minima or maxima. The only thing is we should have a stationary point. That's all. Is this understood or not?
थोड़ा थोड़ा.
हाँ, थोड़ा थोड़ा ही. बस इसमें तुम्हें ध्यान रखने वाली दो चीजें हैं. पहली चीज ये है कि लैग्रांजे मल्टीप्लायर लगता कहाँ है. ओके? लैग्रांजे मल्टीप्लायर हमेशा वहां लगेगा जहां तुम्हें फंक्शन दिया है और रिस्ट्रिक्शंस दिए हैं. Okay? This is first step. You should have function with restrictions. Every restriction will introduce one lambda. So if you have just one restriction, then Lagrange function will be this. If you have two restrictions, then Lagrange functions will be like this. Okay? To find the stationary points, we simply do this. Okay? With the help of this, we find x, y and z as some function of lambda, something into lambda. Okay? Then we put these values in phi. That will give us lambda. Once lambda is known, x, y and z are known, you put this x, y and z in f. That is our extremal value. Process is understood?
Yes, ma'am.
Now I'm giving you one question. You try it out. The question is, find the maximum and minimum distance and minimum distance of the point 3, 4, 12 from the sphere x square plus z square equals to 1. Okay. Find the maximum and minimum distance of the point 3, 4, 12 from the sphere this. Okay. So how do we start? Suppose we have a point P, X, Y, Z on the sphere. Fine. So its distance from this, if you write this distance as D, then D is right. It is better if we take it as D square and treat this D square as F and write it like this. Okay. Now this is the function that you are looking for maximization or minimization, right? Now what is the restriction? You are taking the point XYZ on this sphere, right? That means your phi is this fine?
Yes, ma'am.
Now you have phi, you have f, it is expected of you to find. Since it is asked max and min, it's obvious that you will get two values of x, y, z. And for those two values of x, y, z, you have to get the distance.
फिर लास्ट में पता कैसे चलेगा कि कौन सी मैक्सिमम या मिनिमम अगर वेरिएबल फॉर्म में
जब
है तो
नहीं वेरिएबल नहीं आएगा ना, आपको लैम्डा की कुछ वैल्यू मिलेगी, लैम्डा की दो वैल्यू मिलेगी, क्वाड्रेटिक आएगा। तो जब डिस्टेंस निकालोगे तो डिस्टेंस तो पता चल जाएगा ना कौन सा कम है कौन सा ज्यादा।
इसमें माय थॉट इट विल कम इन वेरिएबल सो हाउ कैन
नहीं नहीं नहीं, इट विल नॉट कम इन वेरिएबल। So you try this question by the time I am taking your attendance.
Ma'am,
Yes, beta.
ma'am, I have a doubt in assignment 2.
You have?
Doubt in assignment 2.
So we should decide when do we discuss the doubts.
Yes.
Okay. This is the extremal point is the last concept. This we will discuss with the doubts of this particular thing.
Okay, ma'am.
Others also, please finish your assignments and keep the doubts ready with you. Next class I will take for the Lagrange multiplier questions and then doubts only. All right. By the time if you
And
want
when
to,
we have to submit the assignments?
the day our module is over, I'll give you 2 more days to finish it.
Okay, ma'am.
Just hold on, I am opening this Amazon.